So in this particular session, we are going to talk about something called as error, that is type of error, what kind of error can actually be incorporated in a measurement system. Okay, we have been talking about measurements throughout, instruments, how the measurements are taken, how the measurement system is designed. So whenever we are talking about measurement, then an important thing that comes into consideration is something called a measurement error. Whenever we are taking any measurement, there is very much likelihood that we come across some type of error in that measurement. So in today's session, we will talk about the types of errors. That is, what are the different types of errors that can get incorporated into the measurement that we are taking. And secondly, the combination of quantities having some errors. For example, if you are finding out some equivalent resistance, which is made up of further two resistances, and if your basic two resistances, they have some errors in it, then what will be the resultant error in your final resistance that you are calculating? So that is combination. Your base quantities have some error. So on the basis of that, how will you find out that your final quantity that you are calculating, how much error it is having? That is basically how the error is propagating into the quantity, which is further made up of certain quantities. Okay, so these are a couple of things that we are going to talk about. It's a very easy session today. So first thing is, what is error, or you can say what is uncertainty that we talk about? All the measurements have some degree of uncertainty that may come from different sources. The process of evaluating the uncertainty associated with a measurement is often called uncertainty or an error analysis. Now, it's very common for us to actually talk in these terms whenever we are talking about any measurement. We say, suppose the value of voltage, if we have to talk about, we say 5 volts plus minus 1. Okay, or we can say suppose 10 volts plus minus 2. Now, when we say this plus minus 1 plus minus 2, we say that plus minus 1 or plus minus 2 might be the possible error, or you can say the maximum possible error that might come into the measurement when we are performing it. Maybe due to the instrument, maybe due to the observer, maybe due to the operator who's using the instrument, maybe due to some environmental changes. So factors can be anything, but this plus minus that you say, plus minus 2, plus minus 1, that is the level of uncertainty or the level of error that can actually be expected in the measurement that you are taking. So measurement can actually be considered as the best estimate plus minus the uncertainty units. Okay, so now how many different types of errors are there? This is although very common, and you already know all this. We are just putting it into a formal note. So the first one could be a gross error. Now, gross error arises due to human mistakes in reading the instruments and recording the results. Okay, great care should be taken while taking the readings and do not rely on single reading. Now, when we say reading the instrument and recording the result, for example, when you were reading the instrument, you had the measurement reading as 8.50. But when you were recording it, or maybe when you were writing it down, you wrote it as 8.05. What you read was actually 8.50, but by mistake, when you were recording it, you wrote 8.05. So that is a gross error. So that is due to a human mistake. You are reading something else, but you are recording something else. Okay, in this particular case, the best possible thing to do is have multiple readings or cross-check your readings multiple times. That can give you a correction for the gross errors if they have by mistake come into the recording of the results that you have made. Then there can be systematic errors or there can be random errors. Now, random error is caused due to some disturbance which we are unaware. Random is the best thing to explain. Something we don't know. There is an error, there is some disturbance, there is some noise, but from where it is coming, we don't know. Okay, so when we don't know about it, most of the times we cannot do anything about that. And we have certain systematic errors. Systematic error means there are certain errors about which we know that from where they are coming, and we can actually do something about it. So under systematic errors, either we can have instrumental errors, we can have environmental errors, or we can have observational errors. Instrumentational errors could be like, for example, your instrument is having some zero error, okay, and the operator doesn't know about it, then it is going to obviously incorporate some error into your reading. Okay, so the instrumental errors can arise due to three main reasons. First thing is due to the inherent shortcoming in the instrument. Inherent shortcoming in the instrument means when the instrument was being manufactured, the mechanical structure that has been designed might have certain shortcomings into that. Okay, now this, how we can reduce this? Correction factors can be applied after determining the instrumental error, or the instrument can be recalibrated very carefully. Okay, so correction factors means if suppose there is some error in the instrument, some constant error coming in the instrument which you already know. So whatever readings you are getting, you can actually apply a correction factor on those readings to get the final values. Or if the instrument has got out of calibration, with due time, when you're using an instrument again and again, it goes out of calibration. So that is why at a repeated interval of time, all your instruments, your measuring devices should be recalibrated very carefully by using some standard. Okay, we had talked about a little bit about calibration. That is when we compare the reading of our instrument with some primary standard, some recognized standard in a recognized laboratory, then we call that as calibration. So from time to time, your instruments should be recalibrated in order to remove the instrumental error. Then due to misuse of the instrument, now when I was like talking about zero error, like the fault of this can be because of the fault of the operator who is using the instrument. If there is suppose zero error in the instrument and your operator doesn't know, or maybe before starting the operation, he doesn't adjust the instrument to absolute zero, then what will happen? There will be some error incorporated in your reading due to maybe poor adjustments, or maybe due to the zero error that was there in the instrument. And because you don't know about it, your readings may all go out of sync. Then due to the loading effects of the instruments, loading effect ka matlab hota hai when you're using it in an improper range. For example, if you have a voltmeter which is actually designed to measure a low resistance circuit, if you start using it for a high resistance circuit, it is not going to give you a proper result. Okay, so loading effect actually means when you're using your instrument in a range for which it is not designed. Okay, so if you're using an instrument, out of range of that particular quantity, then that will give you some loading effect, or what you say is it is not going to give you the proper reading. So using a improper use of the instrument for the improper range of measurement can actually introduce certain errors in your readings, which is called the loading effect. Once again, to explain it to you, if your voltmeter, for example, has been calibrated for low resistance circuit, and you start using it to measure voltage across high resistance circuit, it will give you misleading results. It will not give you actual results. So this kind of a use is actually called the loading effect of the instrument, and this also contributes to error in your readings. Then you can have environmental errors. This may be caused due to conditions that are prevailing around the instrument. Okay, these may be the factors of temperature, pressure, humidity, dust, vibrations, or external magnetic or electrostatic fields. All these could be environmental errors. Anything that is coming due to something in the surrounding of your instrument can be called as an environmental error. It may be due to some other instrument. It may be due to certain vibration taking place on the platform on which you are taking the measurement. Okay, it might be due to the change in temperature or pressure, humidity, things like that. If you're taking some very important or very critical measurement, in that even slightest change in humidity or presence of dust can actually lead to some kind of an error in your measurement. So all these things which are actually coming from something around the instrument, it comes into the category of environmental errors. Okay, these can be reduced by adopting the following methods. Arrangements can be made to keep the conditions constant as far as possible. Using the equipment which is immune to these effects. For example, if you use the resistance materials having very low temperature coefficient of resistance, variation in resistance with temperature can be minimized. This we had also studied when we were talking about the correction methods for interfering and the modifying inputs, that we can actually have inherent sensitivity in the device that you are designing. Okay, so you can make your instrument very much robust. You can make your instrument immune to the environmental effects by using the right material at the time of fabrication, or you can keep it isolated from the environmental conditions, like keeping it insulated from any magnetic or electrostatic fields. All these methods are going to remove the environmental errors which come into the picture from some surrounding effects. Then there can be an observational error. This is actually very, very common. Observational error का सबसे common example है parallax error. Parallax error का मतलब क्या होता है? Suppose you have a reading on the scale, and if the position of the observer is not correct, okay, if you are seeing correctly above 9 in the straight line above at the 90 degrees, you will find the correct reading. But if you are looking at the scale from some angle, you might tend to end up making a reading a little less or a little more from the actual reading. This happens very commonly whenever you are taking some measurement. Okay, so if you are not directly looking in the straight line, you tend to get a little high or a little low measurement from that scale. Okay, so parallax means if the eye is not directly across from what is being measured, the measuring scale will give you an inaccurate reading. So in this case, actually the reading is not inaccurate, but what you are noting it down is inaccurate. Because if you are not at the best position of the observer, then you might end up calculating a wrong reading. So this kind of an error, which is called parallax, this is one of the examples of observational errors. Okay, then we have something called a limiting error. Now limiting error means what? Limiting error का मतलब होता है the highest possible error that can get incorporated. जैसे हमने आपको बताया, हमने लिखा the accuracy of the instrument is suppose 10 plus minus 2. Okay, 10 plus minus 2, या हमने कहा reading that we are getting is 10 volts plus minus 2. So plus minus 2 actually is the limiting error. That means the maximum possible error that can get incorporated into the reading can be plus minus 2 volts. Either it could be plus 2 volts or it could be minus 2 volts. So the maximum possible deviation that is possible into your reading is actually called a limiting error. So it limits the limits of the deviations from a specified value can be actually called as the limiting error. And the ratio of the error to the nominal value of the measured quantity is usually called as the relative limiting error. So कितना maximum possible deviation हो सकता है उसको हमने plus minus delta A से denote किया. If AS is actually the measured quantity, or you can say the nominal quantity, then the relative limiting error becomes delta A upon AS. Okay. So accuracy is often reported quantitatively by using this limiting error. जैसे मैंने आपको example बताया, accuracy might be 90% plus minus 2%, something like that. So basically the limiting error is the maximum possible deviation that is possible from the specified value, and the ratio of this particular deviation with the nominal value actually gives you the relative limiting error. Now, this was the important thing that I was telling you, that how this limiting error or how the error is actually propagating into the quantities. अगर आपके पास दो quantities का sum है या difference है, product है, तो in that case, the resultant quantity, how the error is being propagated into that, this is a very, very important aspect. And even from your numerical point of view, this is an important thing. So the first thing that we are going to see is that if you have sum of two quantities, then the resultant will have how much relative limiting error. So for example, we have a quantity X, which is further made up of X1 and X2. Okay, now when we are talking about rate of change, there is some deviation in in this particular capital X, that will be dx upon x. Okay, this is the, you can say, the relative change taking place in a quantity X. So these are very, very simple mathematics is there. So that will be the change in x1 plus x2 divided by capital X. I can separate this out as dx1 upon x plus dx2 upon x. Now simple mathematical rearrangement I have done. The first quantity I have multiplied and divided by x1, and the second quantity I have multiplied and divided by x2. This actually doesn't change anything in my equation. Okay, I had x is equal to x1 plus x2. Some change takes place in this dx, and I want to take the ratio. So change in x divided by x will actually be change in x1 plus x2 divided by the capital X. Okay, which I can break as change in x1 divided by x plus change in x2 divided by x. Now individually, I am dividing and multiplying by x1, the first term, and the second term I am dividing and multiplying by x2. So this rearrangement is giving me dx by x is equal to x1 upon x multiplied by dx1 by x1 plus x2 upon x into dx2 upon x2. Now, if you observe this, dx1 upon x1 and dx2 upon x2 are actually the relative limiting errors of the quantities x1 and x2. Okay, so x1 and x2 are the two values that I am going to measure. Capital X is actually the final value that I have to get. Okay, and dx1 upon x1 and dx2 upon x2 are actually the relative limiting errors in quantities x1 and x2. So if I know these quantities, I can actually calculate the relative limiting error of the final value x, that is plus minus x1 upon x into delta x1 upon x1 plus x2 upon x multiplied by delta x2 upon x2. So here x1 is the measured value of x1. Okay, capital X is final value measured. Okay, capital X, and delta x1 upon x1 is the relative limiting error of x1. Similarly over here, delta x2 upon x2 is the relative limiting error of x2. These quantities are known to us. So with the help of this, we can actually find out what could be the maximum possible relative limiting error in the final quantity capital X. And plus minus, always we are going to substitute in this calculation, because your error could be either in the plus direction or it could be in the minus direction. Okay, deviation can be either in the positive side or in the negative side. That is why your in the final quantity, the error could be either plus or it could be minus. Okay, so similarly, now if I know the relative limiting errors of these individual quantities, I can always calculate the relative limiting error of the final quantity. Similarly, we can actually calculate it for the difference, where we have x1 minus x2. Okay, now over here, you will be surprised to see that final formula mein again I have placed 1 over here. Now, why I am placing 1 over here? Because this is the maximum quantity. Now, maximum quantity will be when, if suppose x1 जो है, उसमें error जो है वो positive है, और x2 में अगर negative error आ जाता है, so this minus minus becomes plus, and this will become the maximum possible value of the error that can get incorporated in my final value. How we can do that? If x is x1 minus x2, change in x will be dx upon x, further, which can be written as d of x1 minus x2 upon x, and I can separate it out as dx1 upon x minus dx2 upon x. Again, the simple rearrangement I have done, dividing and multiply by x1, the first quantity, and dividing and multiplying by x2, the second quantity. And by rearranging these terms, I can get delta x upon x. Over here, I can get x1 upon x, delta x1 upon x1, minus x2 upon x, delta x2 upon x2. Now, if when I'm writing plus minus and I have to quote the maximum possible value in this case will be जब x1 जो है वो पॉजिटिव हो और x2 जो है वो नेगेटिव हो जाए. अगर x2 नेगेटिव होगा तो नेगेटिव नेगेटिव becomes plus and that will give me the maximum possible value of this error. इसलिए हमने प्लस माइनस को बाहर कॉमन निकाल के we have placed a plus sign inside. So the formula remains the same. Delta x upon x is equal to plus minus of x1 upon x multiplied by delta x1 upon x1 plus x2 upon x multiplied by delta x2 upon x2. When we talk of the product, we are going a little different. We take the log of this, that is log of x is equal to log of x1 plus log of x2, and then I differentiate these with respect to x. The value that I get is 1 upon x is equal to 1 upon x1 multiplied by dx1 upon dx plus 1 upon x2 multiplied by dx2 upon dx. And when I take the difference dx, if I take it on the other side, I get dx upon x is equal to dx1 upon x1 plus dx2 upon x2. And this can actually be replaced with delta. So the relative limiting error of the final quantity delta x upon x will be equal to plus minus of delta x1 upon x1 plus delta x2 upon x2. So that means that is the sum of plus minus the sum of the relative limiting errors in the individual quantities x1 and x2. Then similar method you can apply when there is a division. In the earlier case, we had log plus. Here we will have log minus. That is log x is equal to log x1 minus log x2. And again, when I take the difference with the same derivation, what we had done over here, we are going to get the similar expression dx upon x is equal to dx1 upon x1 minus dx2 upon x2. And just as I had told you in the difference formula, maximum possible error will be when x1 is positive and x2 is negative. Agar x2 negative hoga, so minus minus becomes plus, and that will be the maximum magnitude of the error that is possible. So again, delta x upon x, I take plus minus common, and the maximum magnitude becomes delta x1 upon x1 plus delta x2 upon x2. When we talk of the power factor, that is if your x is equal to x1 raised to the power n, then again if I take the log x will be n into log of x1. Following the same method, I differentiate it with respect to x. I will get 1 upon x is equal to n into 1 upon x1 into dx1 upon dx. I rearrange these terms, so then I get dx upon x is equal to n into dx1 upon x1. This difference can actually be replaced by some small change delta. So delta x upon x becomes plus minus again for the maximum possible values. Either it could be in the positive side or it could be on the negative side. It can be plus minus n delta x1 upon x1. Okay, so these formulas, now let us see, for example, if you have this kind of a question that the resistance of a circuit is found by measuring the current flowing and the power fed into the circuit. The limiting error in the measurement of resistance when the limiting errors of the measurement of power and current are respectively plus minus 1.5% and plus minus 1%. Now this is one practice problem that we are all going to solve it. You are going to solve it and see that how you can actually apply the method. So the formula for resistance in terms of power and current is P divided by I square, okay, which can be written as P raised to the power P into I raised to the power minus 2. Now see, power and current के limiting errors आपको पता है, so you have to find out the limiting error in resistance. तो अगर आप इस formula को ध्यान से देखोगे, R is equal to P into I raised to the power minus 2. इसमें हमारे पास दो formulas fit हो रहे हैं. एक formula है I raised to the power minus 2 and एक formula है P multiplied by that. So what you will do is first put the formula of quotient. Quotient का formula था n multiplied by the limiting error in I. So what we are doing is 2 multiplied by delta I upon I. एंड देन जब हमने देखा था कि दो फैक्टर्स को मल्टीप्लाई करते हैं उस केस में क्या होता है, लिमिटिंग एरर्स ऐड हो जाते हैं. सो डेल्टा पी अपॉन पी प्लस 2 into delta I upon I, and of course plus minus for the maximum range. If you solve this, you will get the limiting error in resistance. So power का limiting error हमें 1.5 दिया है and current का limiting error 1 दिया है, multiplied by 2, so you will get 1.5 plus 2 into 1. That will give you the final limiting error of your resistance.